Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem using the concepts of derivatives. So as per the problem, an electronics store is selling personal CD players. The regular price for each CD player is $90 and during a typical 2 weeks, the store sells 50 units. And past sales indicate that for every $1 decrease in price, the store sells 5 more units during 2 weeks. And we have to calculate the price that will maximize revenue. So as per the problem, so the current price is $90 and the store sells 50 units every 2 weeks and they want to know what the new price should be so that they can maximize revenue. So we'll have to write an equation for revenue for this situation, and for that we need a variable. So we'll use x, which represents the number of $1 in decreases in price. So x represents number of $1 decreases in price. So x represents by how many times the $1 price should be decreased. So should it be decreased just once? So that means the new price will just be $89, or should it be 2 times? So then it will be $88 and so on. So now we'll have to write the expression for the new price. So the new price of the CD player will be the current price $90 minus 1x, because we are using the variable x as the number of $1 decreases in price. And then the new unit sales, the number of CD player sold will be, so the current price, so 50, so the current value is 50, and then the store will sell 5 more units for every $1 decrease in price, so it will be plus 5x, because for every $1 decrease the store will sell 5 more units. So now we can write the new expression for revenue. So we'll use the letter R. So R equals, so it will be the new price, which is 90 minus, so instead of 1x we can just write x times the new unit sales, and that will be 50 plus 5x. So this is our revenue function. Now we can simplify this function by distributing the terms in the parentheses. So we can use the FOIL method. So we get R equals, so first we do 90 times 50, which is equal to 4,500, and 90 times 5x, which is equal to 450x, and then negative x times 50, which is negative 50x, and then negative x times 5x, which is minus 5x squared. Now we can rearrange the terms and start with the highest power of x. So negative 5x squared, and then we can combine like terms 450x and negative 50x. So we get 100 and plus 1500. So this is the revenue function in terms of x. Now we can find the domain for this function. Now the price, the new price that the store charges cannot be less than 0, because if they charge a price equal to 0, then they will not earn any revenue. So that means 90 minus x, the expression for new price, should be greater than 0. And now we can solve for x in this inequality. So we subtract 90 from both sides. The 90's on the left side cancel each other out. We get negative x is greater than negative 90. And now we can divide both sides by negative 1. And by doing that, the inequality sign will flip. That means x should be less than 9. So this is the upper limit for x. Now the unit sales also should be greater than 0. So that means we can set the expression for 50 plus 5x as greater than 0 because they cannot be less than 0, and if they are equal to 0 then the revenue will be 0. So now we can again solve for x. So we can subtract 50 from both sides. 50 is on the left side will cancel each other out. So we get 5x is greater than negative 50. And now we can divide both sides by 5. So the 5's on the left side will cancel each other out. And we get x is greater than negative 10. So that means the domain for this function is that x should be greater than negative 10 and less than 90. So any x value we find should be in this domain. Now we have to find the price that will maximize revenue. That means we have to find the x value at which the graph of this revenue function forms peaks. And at peaks, the slope of the tangent will be equal to 0 because at those points tangents are horizontal. So we'll find the derivative of this revenue function and set it equal to 0 to find the x values at which this function forms peaks. So now we'll find the derivative. So r prime equals, so we find the derivative of the first term. So for the first term, negative 5 is the coefficient, so it will stay as it is. And as per the power rule, the derivative of x squared is equal to 2x. Then plus, now 400 is the coefficient, so it will stay as it is. And the derivative of x is just 1. Then 4500 is just a constant, so its derivative is equal to 0. So now we can simplify this expression and we can set the r prime equal to 0 because we have to find the x values at which the tangent is horizontal. So 0 equals, so negative 5 times 2 is negative 10, so negative 10x plus 400. So now we can solve for x, so we can add 10x to both sides to isolate x on the left side of the equation. So the 10x is on the right side, cancel each other out. We get 10x equals 400. And now we can divide both sides by 10. So the 10 on the left side will cancel each other out and we get x equals 40. And this value lies in the interval we found. So this is a valid answer. Now we'll calculate the revenue at 3x values, negative 10, 40 and 90 and see which x value gives us the maximum revenue. So we'll use the revenue function we found here. So r equals negative 5x squared plus 400x plus 4500. So we'll start with x is negative 10. So we'll find r at negative 10. So we'll sub in x as negative 10 in the revenue equation. So we have negative 5 times negative 10 squared plus 400 times negative 10 plus 4500. So r negative 10 is equal to negative 500. So negative 5 times negative 10 squared is 500 and negative 4000 plus 4500. So r at negative 10 is equal to 0. Now we'll calculate the revenue at x equals 40. So r at 40 equals the same revenue equation. So negative 5 times 40 squared plus 400 times 40 plus 4,500. So revenue at 40 equals, so first we'll evaluate the first term. So negative 5 times 40 square is 8,000 or negative 8,000. And then plus 40 times 400 is equal to 60,000. And then plus 4,500. So when we add these terms, I got 12,000 and the unit is dollars. So $12,500. Now we can find the revenue at x equals 90. So r at 90 equals, so negative 5 times 90 squared plus 400 times 90 plus 4,500. So r at 90. So negative 5 times 90 squared is equal to negative 4,500 and then plus 36,000 and then plus 4,500, and when we combine the terms, so we get 0. So that means the revenue is maximum at x equals 40. We have to find the price that will maximize revenue, and for that we'll sub in x as 40 in our expression for new price. So we get 90 minus 1 times 40. Now 1 times 40 is 40 and 90 minus 40 is 50. So the unit is dollars. So this should be the new price that will maximize revenue for this store. So these are the steps you have to keep in mind to solve a problem like this one. So it's very important to first identify the variable that we can use to write the equation. Then we figure out the expression for the new price and the new unit sales, and then we use that to write the revenue function. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.